To establish that our results are statistically significant using hypothesis testing, you need to calculate how likely it is that your results are due to chance. In order to calculate this probability, you need to have a hypothesis about what the results would be if your experiment had no effect. In the Audacity example, we'll collect two samples, a control group with the orange button and an experimental group with the pink button. We've already assumed that each group follows a binomial distribution, but the probabilities might be different for the two groups. I'll call the probability that someone in the control group clicks pcont for control, and the probability that someone in the experiment group clicks pexp for experiment. This potentially gives two different distributions. If changing the button color had no effect, then we would expect the two groups to have equivalent distributions, so they would be right on top of each other. In other words, p-control and p-experiment would be equal. Another way of saying this would be that p-experiment minus p-control equals 0. This hypothesis of what our results would look like if the experiment had no effect is called the null hypothesis, and it's also represented as h0. We also need a hypothesis about the results if the experiment does have an effect. This is called the alternative hypothesis, or HA. In this case, if changing the button color does have an effect, we expect that p-experiment minus p-control is not equal to 0. Once we've defined these hypotheses, we can estimate p-control and p-experiment from the data we've collected. Then we'll calculate the difference between these and compute the probability that this difference would have arisen by chance if the null hypothesis were true. Then we want to reject the null hypothesis and conclude that our experiment has an effect if this probability is small enough. This is the same type of significance threshold as a confidence interval, so it makes sense to choose the same cutoff. Thus, we'll choose the same cutoff as before and reject the null if this probability is less than 0.05. This cutoff is also called alpha. Now suppose you're running an experiment where you have changed the checkout flow of an online shopping website. You test the effectiveness of your change by running an experiment where some users check out using the old flow and some using the new flow. For each group, you measure the proportion or the probability who successfully complete the checkout. What null and alternative hypothesis would you choose for this experiment? There could be multiple valid answers, but choose a formulation that you think would work. Share your response in plain English in the forum thread linked in the instructor's notes. Then read the response of the person above you in the thread, compare their answer to yours, and leave a comment with your thoughts. When you've done this, check this box.